안녕하십니까. H2 미트 컨퍼런스 2024 테크토크의 진행을 맡은 아나운서 김지영입니다. 반갑습니다. 네, 먼저 오전 세션에 이어 H2 미트 컨퍼런스 2024 테크토크 오후 세션에도 이렇게 귀한 시간 내셔서 참가해 주신 참가자 여러분들께 깊은 감사의 말씀 드립니다. 테크토크는 수소 생산부터 저장, 운송, 활용까지 이어지는 수소 산업 밸류체인의 최신 기술 정보 등 글로벌 수소 산업의 최신 기술 동향을 쉐어하는 유익한 세션입니다. 본 프로그램은 9월 25일부터 9월 27일까지 3일 동안 Utilization, Production, Fuel Cell, Storage and Distribution 이라는 총 4개의 주제로 진행이 되는데요. 이제 2일차 오후 세션을 진행하고자 합니다. 그럼 지금부터 H2 Meet Conference 2024 토픽 3 세션을 시작하겠습니다. 총 8개의 강연이 20분씩 진행이 될 텐데요. 토픽 3의 주제는 Breakthroughs in Hydrogen Production Techniques라는 주제로 진행이 되겠습니다. 각 강연이 끝난 후 질의응답 시간을 가질 텐데요. 적극적인 참여 부탁드리겠습니다. 그럼 가장 첫 번째로 아바다 그룹의 Senior Executive Vice President이신 디팍 아그라왈라님께서 Introduction of Global Hydrogen Strategy and New Water Electrolysis Technology라는 제목으로 강연을 해 주시겠습니다. 네, 여러분 큰 박수로 맞이해 주시기 바랍니다.
Thank you. Thank you to all the listeners, and thanks to H2 Meet for inviting Avaada Group to present in such an auspicious conference. I will be making my presentation in English, so you can use your language translator mic in case you want to hear in another language. So I'll split my presentation into two parts. First, I'll give you some glimpse about the Indian renewable energy industry and the energy transition that's happening in India. And second, I'll give you some perspective on Avaada Group and what difference we are trying to make through the green fuels and the green hydrogen business. So if you see, I'm sure you would be aware, India has given a commitment to net zero by 2070. And as a result of its a commitment to United Nations and COP, India has set a target for about 500 gigawatt of non-fossil fuel-based energy by the end of this decade. And in direct correlation to reduce the carbon emissions and the carbon intensity by 45% versus 2005 levels. Now at present, we as a country today stands at 205 gigawatt of non-fossil fuel based energy, and out of predominantly of this 205 gigawatt is solar, wind and hydro, and most of this capacities has been added in the last 15 years. And we have a clear trajectory set by the government to have an annual auction calendar of about 50 gigawatt of renewable energy. so that we can work in the direction of achieving the 500 gigawatt goal by the end of this decade. And not just India stopping at 2030, but we also have a very clear pathway all the way till 2047, where nearly three-fourths of our capacity will be primarily driven by renewable energy. So India is one of the very few countries in the world where you are seeing simultaneous investments happening in all the forms of power generation, but renewable is something which is attracting the largest chunk. A very important and a unique feature that makes India as one of the preferred low-cost destination for the production of green hydrogen and green molecules and like ammonia is the India's large and a single unified transmission network. So till 2016, India used to be divided into 5 different regional transmission grids, but post 2017, the entire country has one single grid at one single frequency. So this allows us, players and producers of electricity like us, to transmit our electricity over long distances to our green hydrogen and green ammonia plants. And as a policy, we also have been received an incentive of waiver of this interstate transmission connectivity charges. So this is one of the very important takeaway which I would like you to take from here is that one single grid, one single frequency is one of the very unique feature of India, and there are very few countries in the world who have this distinction. And not just in terms of the transmission capability, but even in terms of the availability and the congestion. There is hardly any congestion in the grid, and the network is available continuously over 99.5% over a last 10-year track record. Coming to green hydrogen mission, so India actually started and launched a national hydrogen mission way back in 2022. A couple of important policy announcements. It's what you see is on energy banking. So India is also one of the very few countries which allows energy banking with the grid. So effectively, you generate your renewable energy during the course when the sunshine and the wind is available, but you can actually bank that surplus energy with the grid and take the round-the-clock renewable energy from the grid, especially for the green hydrogen, green ammonia projects. So this helps us to ensure that we can abundantly produce sun and wind, and which are intermittent power but may not be available 24 hours. But through a banking concept, 24 hours round-the-clock renewable energy will be available for the production of green hydrogen and green ammonia. And the second and the important policy announcement is also on the single window clearance and ISTS waiver. So effectively, once our projects are operational before 2030, then we will get a waiver of interstate transmission charges for the period of 25 years. So both these policy announcements actually has been set up an enabling environment for India to become one of the lowest cost producers for the green molecules. Green hydrogen mission launched last year has given a very clear set targets of about 5 million tons of green hydrogen production by 2030, which would incrementally mean about a 125 gigawatt of renewable energy electricity. And we would be one of the important contributors for these targets for the nation to achieve. And we look forward to export a substantial part of this production to the markets like Korea, where we see clearly they have a large demand to meet their own decarbonization targets. Now, specific to Avaada, so we are a player in this industry for nearly 13 years within the renewable energy landscape. So we have set a vision for ourselves to become a 30 gigawatt company by the end of this decade, and which would also be supplemented by our backward integration into solar PV manufacturing and a forward integration into the green molecule business. We are environmentally very, very conscious, and as a corporate, we also proud to meet all the sustainable development goals as set by the United Nations. So we being a fully integrated green platform, we take these SDG goals also quite close to our heart. This in a single slide, it sums up our energy transition and an integrated business model. So on the left-hand side, you see we have a equipment manufacturing business wherein we just started our first factory on solar panel manufacturing. And we are in the process of finalizing our technology player for the electrolyzer manufacturing. We are a renewable energy company. So we have, as of now, our portfolio is 100% solar. But going forward, we are adding capacities in all the forms of renewable energy, which is solar, wind, and pump storage hydro, which is going to be an important element for round-the-clock renewable energy. And lastly, we have also ventured into green fuels business. And to start with, we are working on a green hydrogen and green ammonia integrated plant. So within in each of the business, we have very clear-cut targets defined. Like in solar PV manufacturing, our capacity of 1.5 gigawatt is already operational, and we have started work on the second factory of 5 gigawatt, which will be integrated both from wafer to module manufacturing in India. Within the renewable energy business, as I mentioned, we have a target to achieve 30 gigawatt. But we have already secured capacity of 23 gigawatt, which is fully secured through long-term power purchase agreements. And within this 23 gigawatt, our operating capacity is close to 4.7 gigawatt. And all this capacity is slated to be implemented over the next 3 to 5 year period. And within green fuels business, our first project is of 0.5 million ton green ammonia. So that's an ammonia equivalent capacity, and this will have its own dedicated renewable energy capacities as well as green hydrogen and the port infrastructure. So this is our journey since our inception in 2009. So between 2009 and 2016, we were known as Welspun Energy in India. And in 2016, we sold our business to one of our competitor in India, Tata Power. And we started Avaada again in 2017. So if you see, we have been very fortunate to have several firsts. Like we were the first one in Asia and second in the world to start a 151 megawatt project way back in 2013. And again in 2021, we commissioned the world's largest single location solar plant of 1.25 gigawatts. And within this journey, we have been supported by various marquee investors, especially the development financial institutions across the world, whether it's US-based G Financial, and then we had DG from Germany and Asian Development Bank from Asia. And subsequently, we also had few more investors added post 2017. In 2021, we inducted PTT Group's GPSC company of Thailand as our strategic shareholder. And last year, we added Brookfield. So important to note that the largest FDI of Thailand into India is by PTT Group into Avaada, and also Brookfield has selected Avaada as the only green ammonia platform in the world so far. So this is, I would like to give you some color on what we are doing in India as of now within the green fuel space, which is why we are also assembled here. So our first project, the way we have conceptualized is the overall capacity is about, The overall capacity is about 0.5 million tons, which is about 500,000 of tons of ammonia, which is equivalent to 1500 TPD plant. This will need green hydrogen about 270 TPD. Now to produce this kind of hydrogen, what we have designed is an electrolyzer capacity that will be in excess of 600 megawatt. And to get this kind of an electrolyzer output, we would be needing 700 megawatt of round-the-clock renewable energy from the grid, and about 15 MLD of water. Now, we being a fully integrated platform, to get this 700 megawatt round-the-clock power, we are actually setting up a greenfield renewable energy plant of 2.4 gigawatt, which will be a combination of ground-mounted solar, floating solar on the lake, and that would be one of the largest in the world, and also a wind farm of about 700 megawatt. So a combination of this renewable energy capacity coupled with energy banking from the grid, we would be in a position to meet the requirement of 700 megawatt round the clock for our green ammonia and green hydrogen production. Our intent is to set up this plant as well as have a port infrastructure in terms of storage and the pipeline, and then ship the molecule to various customers, both in India as well as globally. And we are specifically targeting the markets like Korea, where the CHPS auction is already underway. So this is the location of our plant. This is the map of India. This is the state of Orissa, which is along the east coast of India, a very mineral-rich state where our plant will be located. This state has 3 ports, and our plant will be near to the Gopalpur port. So it is just about 6 kilometers from the port boundary. So this will ensure that our domestic transportation is minimal, and the molecule can be easily shipped can be easily loaded on the ships for shipment to various countries in the world. And our renewable energy block will be scattered all across the wind, as well as some of the solar will be in Orissa and out here. So, and we can transmit the renewable energy to thousands of kilometers, and that too without paying any interstate transmission charges, which is a policy incentive given by Government of India. So with a combination of this, we hope to secure offtake and potentially set up these plants by, and estimated timeline is about 2028 commissioning. We have done a formal inauguration of the plant as well early this year by the Honorable Chief Minister, and all the various development activities are underway for the project. Since we have assembled here to focus essentially on the hydrogen production technologies, I think there are multiple pathways through which various companies and various research institutions are trying to produce hydrogen. We being users of the technology, we essentially has narrowed down which are commercially available at large scale today, and which can also be available at a reasonable cost and within the timelines. So in our first project, we are predominantly focusing on a combination of alkaline-based electrolyzers predominantly, and maybe have some smaller configuration of PEM-based electrolyzers. Because given our size, there are very few manufacturers in the world which will be able to supply within cost and within the timeline that we are looking at. But we are very mindful of the fact that there are a lot of new technologies currently at development, at various stages of development in terms of their TRL level. And we are open for technology collaborations with any of the companies out here in Korea or in other parts of the world to, in case if they need some support, and Avaada can be one of the important players who can be participate in that technology journey as well. This is my last slide. So basically what we are looking out in Korea and some of the other demand markets, we have multiple opportunities that we can partner and collaborate with. Starting with, India itself is one of the very large renewable energy markets. So there are a lot of opportunities, both as an investor as well as some off-takers who are signatories to RE100 or who are setting up large manufacturing operations in India. We can be one of their vendor of their choice to supply renewable energy. We are also looking, since we just started our solar manufacturing plants, we can look to supply of modules in case there is requirement by customers out here. We are also within the green molecule. This is one of the important element in our scheme of things, which, because Korea we see is one of the very strategic market, and given their strong and the very tough decarbonization net zero targets, We clearly see Korea as one of the largest offtake market, and this is where we are willing to build and invest on. So there could be multiple collaborations as a EPC, as a supply chain vendor, as well as a technology partners, in addition to offtaker and investment partner. And lastly, on the pump storage hydro, because this is a new vertical that we just added, and we clearly see pump storage hydro as a very long-term durations and a long duration energy storage solution, which is 100% sustainable and can have a very, very long durable life. So collaborations are welcome in this space as well. Thank you.
Thank you very much for your presentation. 네, 감사합니다. Let's see if we have questions from the floor.
Yeah.
네, 질문이 있으신 분께서는 자리에서 손을 들어주시면 감사하겠습니다. So maybe we don't have questions.
No
So
problem.
now please return to your seat.
Thank you. Thank you. Please feel free to get back to me in case if you need any clarification. Thank you.
Thank you. 네, 감사합니다. 네, 아바다 그룹이 이번 H2 미트 컨퍼런스에서 한국 기업과 협업할 수 있는 좋은 인연과 기회 만드시기를 바라겠습니다. 네, 그럼 다음으로 IMI 그룹의 비즈니스 디벨롭먼트 디렉터 하이드로젠이신 안드레아 푸세두 님께서 IMI VIVO, a safety-driven design for skid-mounted or containerized PEM electrolyzers 라는 제목으로 강연을 준비해 주셨습니다. 네, 연사분께 따뜻한 환영의 박수 부탁드립니다.
Hello, good morning, and thank you for coming this presentation. It's my great pleasure today to introduce the company IMI and focusing on our complete portfolio for hydrogen solution, but with more attention on our main product, which we'll present here, which is the hydrogen electrolyzer. So, few words about IMI PLC, who we are. IMI PLC is a public company, is a British company that, just to tell you some number, we have a revenue that was for previous year of about 2.19 billion pounds. We are in FTSE 100 London Stock Exchange, and we are 10,000 employees in 50 countries worldwide, including a wonderful factory that is just 1 hour driving from here in Korea, in Seoul. And we have several platforms which are the process automation, industrial automation. We are also active in the climate control, in the life science and component for automotive and transport. What is the main thread, the main thing that is collecting all this type of different businesses, different geographical location, different type of industry technologies and customer? It's the people. It's the engineering that is in IMI, and my task for today is to try to communicate, to share with you a bit about our people, our product, and our engineering. So, for the hydrogen, since we are here for hydrogen, we are, of course, in the hydrogen production with our WEVO electrolyzer, and we will focus a bit about the electrolyzer. But we have also product for hydrogen pipeline valves, so for gas blending, compressor anti-surge, and general fluid control. We are also very active in the liquid hydrogen product, so we have valve for liquid hydrogen. And also component for storage and transportation. More than this, we have also component for our system platform, but again, IMI, for hydrogen production, refueling, vehicles, transport. We have the priority panel, the back pressure control valve, everything that is related for components for high pressure hydrogen. Now, I will focus, as I said, about our PEM electrolyzer, which is the product that IMI is launching on the market with a very good reaction from the market. And the product is designed and engineered in Italy, in our Remosa business unit in a brand new facility that was just opened 2 years ago, 60,000 square meter indoor, where we have the production of our oil and gas product, because this company comes from the oil and gas, and we will see this is a very important concept I would like to transmit to you. And so all the know-how, all the gray hairs that we got in several decades of experience of very high challenging oil and gas application is the same skill, is the same approach, the same attitude that we are now using also for the new green technology related to hydrogen. Here in the picture you see our beautiful factory. By the way, we are in Italy, we are in Sardinia, a wonderful island, and you should pay us a visit if you're interested about our product, and even if you're not, because in a way, in any case, a fantastic place to have tourism, to go there. You see also our assembly line for the electrolyzer. And some words about our product. We are not going on the market of the huge, big plants of hundreds of megawatt. We are focusing on a portable, containerized and skin-mounted solution based on the PEM technology. We cooperate with stack manufacturer. We don't do the stack. We focus on engineering a robust, industrially proven and ready to operate balance of plant. We are now working in a range that we say that from 100 kilowatt to 5 megawatt. Let's say that, of course, now we are focusing on the upper range of the scale. So we are focusing on the 5 megawatt scale and below, so 1 megawatt, 2 megawatt, 3 megawatt. And we have a very competitive power consumption thanks to a very optimized design of the balance of plant. And what, again, is one of our main attributes, our main goals and focusing is also to do a bespoke design. So we sit down with the customer, we talk to the customer, we speak with the customer, we want to understand what are the expectations. We don't have a catalog, we don't have a standard product. What we do is to design a product around the customer, around the end user needs, okay? And our experience, thanks to our IMI, but to the business, our IMI corporate, but also for the main business of Remosa that is hosting the IMI VIVO brand, we have decades of experience everywhere in the world. We have installation in the oil and gas in virtually any country. We have India, we have Korea, we have Japan, we have China, South America, North America, you name a country, we are there. Okay, and our products are very important because they are products that do a critical control in a refining process and also with the control of the safety of the process. So anytime we speak about safety, anytime we speak about and we deal with safety, with the explosive area, IMI VIVO is a new brand in the hydrogen, but comes from years. 40 years of experience in the oil and gas about the exact same topics. Because regardless of the color of the hydrogen, being gray, being pink, or green, of course, the safety aspects are exactly the same. So, in our booth, we are here at the exposition, and we will be happy to have you visiting our booth. You will see a fantastic model, very huge model we brought, okay, in a trolley from Italy, flying together with us, and you will see this exact model. So our latest design, it's a containerized, skid-mounted. The size is not a standard ISO container; is slightly longer than an ISO container and slightly taller, but this second iteration of our design is specifically meant to make the life of the end user and the installation very easy, even for some aspect. You can notice that differently from other design, this electrolyzer, this container, let me say it, so the enclosure, doesn't have any equipment on the top. This because if you put fan, if you put the coolers on the top, then you will need to do maintenance there. So you need to climb there, you need safety authorizations, safety regulations, and speaking with the customer, we understood that this brings issue, so there is nothing on the roof of our electrolyzer, because everything can be maintained very easily from the sides. And again, if you come and see our model, that will be much easier to understand. Safety is an important aspect on the electrolyzer. And to do this, basically, we are using the same approach and the same technology that and the same procedure also, that we use for our oil and gas application. Now, what is very important and sometimes not very well represented when you speak and we talk about electrolyzer is what can go wrong. Because if we don't understand what can go wrong, we cannot even prevent the problem. So only way to prevent a problem and to avoid the problem is to understand what can go wrong. And it's basically an engineering application of the Murphy law. So anything that can go wrong will go wrong, and so you have to predict this. And we do it in the HAZOP study. So the HAZOP, we mean the hazard operation analysis, is analysis that we do for every electrolyzer, and we do together with the customer and also with a third part, so an independent notified body certification company that will certify that everything has been addressed, firstly identified, and then addressed during the HAZOP studies. So the purpose is to identify any possible hazard, any possible thing that can go wrong. Okay. And the process is done by a systematic, line by line on the PID, component by component, failure mode by failure mode analysis of the complete design of the system. And the outcome are the recommendation for mitigating or removing completely the result. You see here, unfortunately, probably is a bit too tiny to see, but what you see here, it's on the left side, on the right side of the page. It's basically the table of contents of our HAZOP, and you can see there are lots of schematics and pages of information on this very complex document. As a result of the HAZOP, what is done is the seal allocation, so the safety integrity level classification of the system. So we need to work around a potential issue. So we may need a component, we may need a valve that opens, a valve that closes, an instrument that may detect a malfunction. But how and to what extent this instrument is safe, is reliable, that is the seal allocation. So the safety integrity level that will tell this, okay? And this will allow to specify, and depending on the severity of the issue, of the likelihood of the issue, a different seal level. Again, our oil and gas products are seal certified. We are now nearly to get also the seal certification for the electrolyzer. And so, again, we're using same approach and same attitude. In the remaining few minutes, I will just want to show you some other type of studies, okay? And again, those are high-end engineering techniques which have been used successfully in different type of oil and gas application. The animation you see running here right now is the simulation of an explosion inside the oxygen separator. You are familiar, I guess, with the with the electrolysis technologies, but you have a big vessel where you are separating on anode side the water from the oxygen, and this vessel is subject to a risk of explosion. What happens? This type of analysis is simulating the propagation, so at sonic speed, of a spherical shock wave that is starting from an arbitrary ignition point inside the vessel, and can analyze the stresses inside the vessel, allowing the engineers to visualize how the structure reacts, and also to visualize the stresses and the point of concern for the design. But there is more than that. As I told you, in our latest revision of the design, we moved the fans away from the top, okay, for a better safety of the maintenance, which is an important aspect. Every time we design something also thinking about who is going to maintain the system. Here you see a CFD. CFD means computational flow dynamic analysis. So we are simulating a leakage of hydrogen from one of the components, in that case is one of the stacks, okay? And the blue cloud that you see here moving is the hydrogen that is leaking from the stack. So we have the ventilation fans that are used to vent out and to remove completely the hydrogen from the internal enclosure, but to what extent the location of the fan is correct, and to what extent the power of this fan is okay, and how much time do we need to vent. That is important information that goes in the adds-up analysis, on the safety analysis. In order to avoid any assumption, any arbitrary assumption, what we do is to perform an high-end, this is a quite sophisticated type of analysis, a multi-species analysis that takes into account the different, of course, physical behavior of the hydrogen compared to the air, and takes into account the power and the effects of the fan. And so we can prove, first of all, to ourselves, but also then to also the notified body and the customers to what extent the fan is in the best place. And in this way, with this analysis, we can provide again as well a high level of confidence on our design, also on these details that may appear minor details, and they are not. Okay. Finally, another important aspect. Again, we are focusing on what we call portable solution. Okay, even if it's a quite large skid, it's something that you will install, and most for the type of market of application we are at the moment following and we are servicing. Mostly, it's important to understand that those electrolyzers are going near communities. They can be in a city because if there is a fueling station, we can have a school, some offices, some buildings there, and one important aspect is the noise. Anytime you go serious about installing one of these devices, and so you have to deal with local regulation, with health and safety, an important aspect is to understand what is the noise emitted by the electrolyzer. This is quite important, and we do this type of analysis where, because the electrolyzer itself doesn't emit any sound, but the fans and the cooler, they do emit sound. With this type of solution, we can simulate exactly in the planimetry, in the map, where there is the actual location, taking into account building, walls, and protection, what are the noise level, and we can give the proof and the confidence that the noise level are accurate. Some few reference, we have now a backlog, a commercial backlog of around 14 megawatt that we will manufacture by end of this year and end of next year. So the business is doing very good. The first two customers we would like to mention here because they believed us years ago when we started are the Transitional Energy Research Center in Sheffield and the IIPS in Bath, two labs which are doing advanced research on hydrogen and are using our 500 kilowatt electrolyzer. In conclusion, IMI VIVO is a new brand of a very large company, but what I would love you to remember from my speech is that everything is built upon 40 and probably more years of experience of challenging application, real application. We have thousands of valves which are operating right now everywhere in the world in safety. And we are using the same paradigm and same approach in the electrolyzer. And we are at the booth, and we would like to pay a visit, you to pay a visit us and to come here and speak with us, because we can speak your language. Literally, we have a Korean office, but we can speak the language of the customer in terms of understanding needs and providing solutions which are cost-effective, which are professionally made, and which are guaranteed by our experience. We are at booth G24. You can see, you will understand and will note immediately, because we are the only one purple. Okay, so it's very easy to spot. It was a pleasure to be here, and will be a pleasure if you can meet us at the booth. Thank you, everybody.
Thank you very much for your presentation. 네, 혹시 질문 있으신 분께서는 손을 들어주시면 질의응답 시간을 가져보도록 하겠습니다. Now, I think we have times off, and maybe they can visit your booth. And thank you very much for your presentation once again, and please return to your seat. 네, 감사합니다. 네, 일렉트로라이저에서 안전이 가장 중요하다는 것을 다양한 시뮬레이션과 케이스를 통해 잘 보여주셨습니다. 네, 다음으로는 베보 케미 GmbH의 비즈니스 디벨롭먼트 매니저이신 안드레아스 알트 님께서 강연을 준비해 주셨습니다. 강연 제목은 Adhesives, Sealants and Resin Solutions for Fuel Cells and Electrolyzer Stacks and BOP Components입니다. 네, 여러분 큰 박수로 환영해 주시기 바랍니다.
Yes, hello everybody. Very happy to be here, and thank you for the invitation. Yeah, my name is Andreas Alt, working for a specialty chemical company based in Germany. Short look at the agenda. I will cover only a few words about the company, then I talk about adhesives and sealants for electrolyzer and fuel cell stack manufacturing. I have a specific chapter about hydrogen permeabilities of such materials. And then I talk shortly about balance of plant and how the materials are processed or applied. So WEVO is, as said, a chemical company. We are focusing on customized solutions for potting materials, adhesives, and sealants, and we do that exclusively for electrical and electronic applications. The headquarters is in Stuttgart, or near Stuttgart, in the southern part of Germany. And as you can see, we have a quite broad presence in Asia and also a location in the United States. You can find our materials in many, many industries and applications. I will not talk about everything, but in automotive industry, for example, our thermally conductive products are used for battery pack and module assembly. As well as charging infrastructure. And today I talk about hydrogen and fuel cells. And in energy, for example, it's about energy storage, for example. We make materials for flow battery stack assembly as well. If you want to get in touch with us about that, come to our booth. It's in the battery section. It's B700. We have 3 different base chemistries, and I will cover all these base chemistries today in my talk. Firstly, we have on the left side, you can see our polyurethane materials. This can be adjusted in a very broad range, thermomechanical properties, from very soft to very rigid. And in the middle, our epoxy adhesives and potting materials. They are basically high strength and high thermal stability materials. And then on the right side, our addition curing WEVO seal materials. These are silicon materials used as gasketing materials, for example, for stacks. So I have a few examples brought with me. I talk about 2 component materials which have to be mixed. I talk about that later. And they are used, for example, as sealant and gasketing material for metallic and also for graphite polymer compound bipolar plates. This is one of the main applications. You see a metallic bipolar plate on the bottom picture. Then I talk, the materials are also used as sealants for the membrane electrode assembly, or the GDL. Then we have adhesives for joining the GTL or the porous transport layer for electrolyzers on the bipolar plate. Then, very important, we have adhesives for joining the monopolar plates to form the bipolar plates. That's essential for the graphite bipolar plates. And we also work on adhesive solutions for metallic bipolar plates as an alternative to laser welding. And also, these materials allow new stack formation technologies and gives you more design freedom. If it comes to the requirements and properties, the materials, of course, must cure very fast. I cover that later. They must adhere to the materials very well, and they need a good chemical and hydraulic resistance. It depends on the electrolyzer or the fuel cell type. They must be resistant under acidic and also alkaline condition. And they must be very pure, low in iron content and low in volatile organic compounds. If you look into sealing or gasket technologies, we have basically three different technologies used today for fuel cell stacks and electrolyzer stacks. It's first of all the use of pre-manufactured, pre-formed gasket, O-ring types or flat gaskets, and do a kind of manual assembly or half-automized assembly. We do not make these materials. Our materials are in the second part. This is the liquid cured or formed in place gasket. That means the material is applied by either a dispensing or a screen printing process directly on the bipolar plate. This is a very fast process. And third possibility is to do a kind of injection molding with thermoplastic elastomers, for example, FKM based or rubber based, typically on the membrane electrode assembly. We do not really do that, so we really focus on the second part. As said, these materials are applied by different technologies and allow a good automation of the production process of stacks, and also allow you a good design freedom. I come now to one of the chemistries, polyurethanes, what we have for this application. As said, we can adjust here the mechanical properties from very soft to rigid. They are high in ionic purity. They have a very good adhesion on many substrates. And if we adjust them soft with a low glass transition temperature, they can act as a sealant and adhesive in the same time. And they may replace silicon elastomers. Why I say that? Because we also have silicons, and I will talk about that later, but one of the advantages of polyurethane is the much lower gas permeability, and that includes hydrogen as well. And I talk about it later. We can adjust the viscosity of that materials from low viscous to really high viscosity thixotropic to apply beads, and the reactivity can be adjusted as well. I don't want to spend too much time on that, but it just shows you some of the examples of our materials. On the left side, low viscosity material. It's a material with a high resistance in alkaline electrolytes, so it's a possible sealant material for AEM and alkaline electrolyzers. In the middle, it's a version of the left one. It's a thixotropic version, higher in viscosity, but basically it's the same chemical basis. And on the right side, there's another material with a little bit softer material. I talk about that in this slide. Look at the picture here. You can see the black gasket on the metallic bipolar plate. In this case, this was applied by a screen printing process. And this material is really low in gas permeability. We have measured that. And it's a silicon-like material. And it's also available in different versions. Reactivity and also elasticity is available in lower elasticity. If I come to the silicon materials, we basically have two ranges. It differs a bit in the hardness. On the left side, you see a Shore A60 material. It's a little bit harder material. This material is resistant, especially in acidic conditions, so it's suitable for PEM electrolyzers. And in the middle, it's a much softer version. You see much more elasticity, higher elongation at break, and this material is also high on thixotropy. And on the right side, it's a silicon material with a good resistance in alkaline conditions as well. Typically, silicons are not so resistant in alkaline conditions, but more in acidic. These are versions with a longer reactivity at room temperatures. We have made them, they are modifications of the material you saw before for screen printing processes. They have long pot life at room temperatures, but then react very fast. If you apply heat, you can do that in a convection oven, but also by infrared heating or by laser heating. Some examples here again. You see on the upper picture a metallic bipolar plate where the gasket, the blue gasket, was applied by a dispensing process. That's the lower viscous material. You can see that the gasket is quite wide and not so high. On the bottom, it's the same material used for sealing of a graphite bipolar plate, and the same material was used to fix the two monopolar plates to form the bipolar plate. If you look at the tensile shear strength of that material, you see it's quite good for a silicon material, because silicons typically do not have the best adhesion. This is the other material I explained, the softer material with the higher viscosity. You see the same bipolar plate here on the bottom picture, but in this case with a catalytic coating on top, and the gasket in black. It allows you to apply higher beads and higher gasket height. And the upper picture I show later when I talk about the application method. This material was especially modified in terms of reducing the hydrogen permeability. As said, silicons have a high gas permeability, but this material is rather low in hydrogen permeability. We also tested these materials in stability in glycol water mixture in glycantine FCG20 by BASF. We exposed them at room temperature and elevated temperature 90 degrees. You can see there's not a big swelling or visual change of that materials. And we also looked at the change of the shore hardness of the test specimen, and also if they lost some weight. And you see the weight loss on the left side is below 1%, which is a good sign for the stability of that materials in the mixture. And on the right side, you see the hardness. It's slightly post-curing. There's no hardness degrees. A hardness degrees would be a sign of a low stability. I want to spend a few words on the epoxy adhesives. We made that materials for assembly of alkaline electrolyzers because this material is really very much resistant in alkaline electrolytes, so in hot potassium hydroxide solution. It has a very, very good adhesion on many substrates, as for example nickel and titanium, which is also not so easy. And in a low viscous version, as shown here, it's suitable as a potting materials to make flow frames, for example. And in a thixotropic version, as WEVOPOX VP414, it allows you to apply adhesive beads. I promised to say a few words about the hydrogen permeability. We did that test at the Sept. It's a research center for hydrogen located in Germany, in Duisburg. I do not want to cover too much about the techniques, but they calculate the permeation rate and the permeation coefficient. And the rating you see here is not by ourselves done, it's a rating by the Sept Research Institute. And you see that values below 100 are fine, and that the silicons have a special own rating. What is a sign, what I said, that silicons are really high in permeability. And we could also confirm that by our measurements. On the left side, you see the blue columns. These are the polyurethane materials we measured. You see they are all below 100. And on the right side, you see the green bars. These are the silicon materials. They are much higher. The blue material I showed you is about 500 in permeation, which is high, but still lower than the 1,000 what they accept. And you see the middle bar, it's the WEVO seal 28002, which is really low in permeability. I come to the balance of plant applications. These are basically also adhesive solutions for the production of different filter systems, and especially the humidifier modules used for fuel cell systems. The requirements are quite similar, and also the properties. That's why we also typically take the same materials as I showed you before for the fuel cell stacks. With exception of humidifier modules not made with flat membranes but with hollow fiber membranes. There are a couple of companies here showing that, where the hollow fiber bundle has to be encapsulated or potted at the both ends in a tube, and we do that with suitable potting materials, for example, based on polyurethane. And then finally, some words on the power electronic devices where our material are used, for example, for DC-DC converters, the electronic control unit of the fuel cell system, or the onboard charger. And here our materials are used typically as thermally interface materials or as thermally conductive potting materials, for example, for the power electronic device, and also the inductive components, the chokes and the transformers used in the devices shown here. And these typically are flame-resistant, UL-approved systems. The material are, as said, two-component materials. They have to be mixed firstly in the right mixing ratio, and then applied with a typically CNC machine, or as said, by screen printing in the future with the silicon materials especially. And on the left picture you can see a print head with the two cartridges of the resin and the hardener component. And on the right picture, the static mixing tube where the materials are mixed and then dispensed via the needle, that green thing, directly into the groove of the bipolar blade, for example. As said, we are working on solutions especially for the silicons, for screen printable materials. For the polyurethane, that's at the moment a big challenge. And then we also look into liquid silicon rubber formulation, as said, for the injection molding to be done directly on the membrane electrode assembly. The materials are principally room temperature curing, but it would take too long, so we apply heat, and as said, we can do that either by convection ovens or by near infrared heaters. And we have a research project going on with the Technical University in Aachen, where we use laser welding. And this is a very fast process. Yeah, with that, I already come to the end of my presentation, in time, I see. Yeah, I hope I could show you that we developed new, let's say, techniques to apply the sealing or the gasket on the bipolar blade, which allows also better stack design and more design freedom. And we focused especially on materials with a low hydrogen permeability. As said, polyurethane are versatile materials where you can adjust the mechanical properties in a very wide range, and they can be used as sealant and adhesive in the same time. Yeah, as said, the polyurethane materials have a low gas permeability, but at the end we found a solution for the silicons as well, especially with the WEVO seal 28002 grade. Yeah, with that I'm finished the presentation. I thank you for your attention, and please, if you want more information, I have some nice brochures here where everything is described, and you can also come to our booth B700 in the battery part of the show. Thank you very much.
Thank you very much for your informative presentation. And let's see if we have questions
Yes.
from the floor. 네, 질문이 있으신 분께서는 자리에서 손을 들어주시면 마이크를 전달해 드리도록 하겠습니다. 네, 네, 마이크 전달 부탁드리겠습니다.
Okay, so I have one question. So particularly you said that silica could have, of course your silicon materials are very stable, but in case that silica materials leach for PEM electrolyzers, what kind of impacts happens on the catalyst side?
It can have an effect on the membrane stability and lifetime of the membrane. So that's why we now, it was a learning process, I have to say. We started with the development of such materials a couple of years ago, and in the beginning we were not aware of these facts. So we really use very clean material. We do formulations where we avoid ions, for example, which could leach out.
It could leach out also.
Yes,
Okay, thank you.
you're welcome.
네, 더 이상 질문이 없으시면 다음 강연으로 넘어가도록 하겠습니다. Thank you very much once again, and please return to your seat. 네, 감사합니다. 네, 연료 전지와 또 일렉트로라이저에서 다양한 소재가 사용된 사례와 테스트 결과를 공유해 주셨습니다. 유익한 강연 대단히 감사합니다. 그럼 계속해서 ITM 파워 APEC의 매니징 디렉터이신 네일 탐슨 님께서 Towards the Australian PEM Gigastack for Industrial Decarbonation 이라는 주제로 강연을 준비해 주셨습니다. 네, 여러분 큰 박수로 환영해 주시기 바랍니다.
So just what are we doing? Clicking the big one? Laser pointer. Okay, thank you so much for that. Well, good afternoon, ladies and gentlemen. It's a pleasure to be here today to share some insights into how we get to the gigawatt scale water electrolyser in Australia that we need for industrial decarbonisation. I guess these insights are based on my experience not only as Managing Director of a large electrolyser OEM, but also from my pro bono work for various universities across Australia, international chambers of commerce, and the AICD Academy in developing net zero education programs for Australian directors. Having built 4 ITM brand electrolysers in Australia since I returned in 2018, and also acted as university consultant on another 5 projects that have successfully achieved FID, I always like to start these presentations with a reality check on the gigawatt scale electrolyser project claims that we see in the press across Australia and the wider APAC region. So here on the left-hand side, we have the world's largest electrolyser that was built in 1950s at around 165 megawatt scale. So we really haven't done gigawatt yet. In China, we have the Kucha project, currently nameplated at 260 megawatts, operating at around 80 megawatts. In terms of historical development of electrolysers, the AL or alkaline type was first in the 1800s. And here we see the capacity worldwide. This is the most mature technology from both the technology readiness level and also commercial readiness index. In the middle, we have the PEM type, that we currently manufacture at ITM, as the next most developed technology, with future expectations for solid oxide and also AEM. In terms of future efficiency improvements and also future cost reductions, we're about at the level of technological development for PEM. Now we're looking to solid oxide and potentially AEM. And the aim is to basically meet the current parameters for alkaline. Now, in terms of the different types of electrolyser technology, they're each suited to different types of renewable electrons for input. The traditional alkaline electrolyser is best suited to steady-state hydropower, which was the first example I showed you from the 1950s, whereas the PEM type, which we're currently working on around the globe, is best suited to variable renewable energy from solar and wind. And next we have the solid oxide type, which is best used in industrial situations where we have waste steam. Now, our journey in Europe in terms of scale-up of electrolysers started at the left-hand side at 2 kilowatts in around 2002. And we've scaled up now to 200 megawatts on the right-hand side there, which is the RWE project in Germany, based on the Wuppertal Institute's Factor 10 approach, where we're always taking a by 10 improvement, so going from 2 kilowatts to 200 kilowatts, etc. In terms of our experience in Australia, our first 4 electrolyser units in Australia were from the 0.2 megawatt unit up to the 2 megawatt unit, so that we could actually get experience with local codes and standards, and also to develop an after-sales team, which is very important in a large country like Australia. Since 2023, we formed a joint venture partnership with Linde Engineering as our EPC partner, and we also received a 20% injection of capital from Linde Gas AG. Now we're working exclusively to bring Trident electrolyser stacks into Australia and combining this with local external balance of plant to get to at least a 30% local content. That's up to the 200 megawatt scale currently to 2028. By 2030, we're hoping to work with our Korean partners to achieve the gigawatt scale. In terms of electrolyser costs, over the last decade, we've received information to show that we've reduced PEM electrolyser costs by 50%. By moving to the gigawatt scale, we're moving to another 50%. So the aim is to achieve the same cost reduction over the next 5 years. Now, one of the things that's helped us, like the battery industry as shown on the left-hand side for Mr. Musk, basically we have the ITM Gigafactory on the right-hand side, which is using the gigawatt scale production, which is again helping us to reduce costs. Now, the lessons learnt from those 9 projects in Australia, one of the key things we've learned is that this is not about hydrogen versus batteries. This is about integrated sustainable design. This is about the 2 technologies working together to achieve a 1 + 1 = 3 outcome. And basically we found that hydrogen is certainly not the Swiss Army knife of the road to net zero. It has to work with other technologies. Now, one of the key things we've learned in these projects as well is that the cost of input electrons constitute up to 70% of the dollar per kilo cost of the produced hydrogen. So it's critical to find low-cost sources of electrons, which Australia is blessed with in terms of PV and wind utilisation factors. Now, one of the other things we've learned from our lessons in Australia is basically we must have multiple offtakes. So a portfolio of offtakes, typically from mobility, power generation, whether we're using a gas turbine as shown there or a fuel cell. I've met many wonderful fuel cell manufacturers in Korea this week, but also looking at waste heat. It's something that's not often looked at in electrolyser projects. So we can use that waste heat directly for water cooling and from an absorption chiller as shown there, but also we can use it for developing hot water for domestic applications. And finally, we have industrial chemistry. One of the unsung heroes of projects is basically oxygen. So we're looking at how we use that both in industrial and future medical applications. Now, one of the other great things about PEM electrolysers is their ability to ramp up, ramp down very quickly. In Australia, like the US, we have a problem with the duck curve. During the day, we have this opportunity where we have low cost or zero cost or even negative cost electrons. So we're basically turning the electrolysers on quickly to take advantage of those low cost electrons. Then when the grid comes back on into the evenings for the evening peak, we can turn them off quickly. So we earn money in Australia, like California, from demand response and frequency control by turning the PEM electrolysers on and off. So again, those incomes that we derive from those frequency services and demand response services can actually improve the IRR for electrolyser projects. Now, one of the things we've learned is working with our various state governments in Australia and also local CRCs or cooperative research centres from our universities, and also local hydrogen hubs that have been put together by the private sector and typically local government. A good example of this is the work that my host here this week, Mr. Kyu Hong Lee of Alexseed, is undertaking with his team in Australia, headed by my good friend, Mr. Robert Saunders, and his able-bodied assistant, Mr. Justin Werner, basically to work with major clients such as the Hallett Group on world-class green cement projects in partnership with Korean developers, including KHNP. Now, one of the things we've also found is that there's an opportunity. We've been working with the Industry Capability Network in Australia under Net Zero Manufacturing's initiative, EAD program, to look at local supplies of power supply units, but also critical balance of plants, so cooling systems, deoxy dryer units, and also water reverse osmosis units. So we can reduce the cost per kilowatt for the total system, but we're also reaching 30 to 60% local content, which is often needed for some of our projects with government procurement. I guess one of the exciting things we've been discussing here in Korea this week, I've taken my host, Mr. Kyu-hong Lee, to the UK Embassy. The UK government is offering 20 billion sterling for funding clean tech manufactured projects from the UK, including ITM. In essence, this is enabling us to take the cost of projects off the balance sheet and move it to the profit and loss statement as an OPEX. So basically, we're turning this into tens of cents a kilo over low interest loans from between 10 to 20 years. So in essence, this is the same process that we follow in the airline industry, where we're leasing engines and not buying engines. So it's a well-proven financial strategy. One of the other things we've been doing is working with the ASX 200, the stock market in Australia, and learning from the net zero plans of directors in these ASX 200 boards. So we're synthesising this with the UWA University under their net zero program, and developing education syllabus for directors in Australia to show them the sensible and commercial use of hydrogen. Again, it's not the Swiss Army knife of net zero, but it's a critical element in those hard-to-abate sectors such as cement, steel, and also the iron ore. So I guess from our experience in Europe, we're really looking at how we include what we've learned from the 200 megawatt scale-up so far in the EU. We combine that with the generous offer from the United Kingdom in terms of funding clean tech, particularly the stacks for these projects, to take them off balance sheet, put them onto P&L, and work with our Korean development partners with the Australian market in terms of the low-cost electrons, and also the opportunity to work with the local supply chain to further reduce dollar per kilowatt system cost, but also to reduce the overall life cycle cost of the project. So I guess that's really what we've learned, and we'd be very happy to share these lessons. We're on the Austrade stand with our colleagues at Alexseed, so we'd love to talk more. So thank you very much for that, and happy to take any questions.
Thank you very much for your presentation. And let's see, we have questions from the floor. 네, 질문이 있으신 분께서는 자리에서 손을 들어주시면 마이크를 전달해 드리도록 하겠습니다. 네, 질문이 없으시면 다음으로 넘어가도록 하겠습니다. Thanks again, and please return to your seat.
Thank you.
네, 감사합니다. 네, 호주 정부에서 또 학교들과 협력하여 얻은 그런 내용들, 교훈들을 잘 공유해 주셨습니다. 네, 그럼 잠시 휴식 시간을 가진 후 2시 55분부터 세션을 이어서 진행하도록 하겠습니다. 편안한 휴식 시간 보내신 후 다시 뵙겠습니다. 감사합니다.
The shift towards a decarbonized society is accelerating. H2 represents hydrogen and humanity, the two main pillars of Hyundai's hydrogen business, leveraging the group's wide-ranging capabilities in various sectors beyond automobiles. Hyundai's H2 vision spans across the entire hydrogen value chain, from production to its utilization across industries. Hydrogen fuel cell technology brings significant advantages, like extended range and fast refueling capabilities. The H2 fuel cell system, created through more than 20 years of research and development, represents Hyundai's commitment to creating a new wave for a hydrogen society. Clean energy based on hydrogen, paving the way for a sustainable future.
When you think about net zero aspirations, you need lower carbon systems that can work in the process and the heat that we need to work with. Hydrogen, from that perspective, is a very versatile molecule in the energy transition. It has applicability in the transport sector, especially in heavy-duty transport, where we can use it with existing combustion engines or with fuel cells. But it can also be used as a direct combustible fuel in industrials like cement and steel. These are big investments, and they offer big potential for lowering risk and carbon intensity for all kinds of consumers and companies. Chevron is uniquely positioned to lead the way forward.
We're a fully integrated energy provider enabling new energies for a growing world. And because we are Chevron, we have an opportunity to lead the way.
네, 여러분 편안한 휴식 시간 보내셨나요? 그럼 계속해서 다시 테크토크 오후 세션을 이어가 보겠습니다. 이번 강연은 인투코어 테크놀로지의 데퓨티 매니저 앤 프로페셔널이신 모삽 바니살만님께서 준비해 주셨는데요. Advanced steam method reforming via high power inductively coupled plasma torch with combined catalyst at atmospheric pressure라는 제목으로 강연을 준비해 주셨습니다. 네, 여러분 큰 박수로 맞이해 주시기 바랍니다. 인투코의 시스템 플라즈마에 대해서 알아볼 수 있었습니다. 네, 그럼 계속해서 브롱크호스트 하이텍 BV의 마켓 디벨로퍼이신 피터 브라워님께서 강연을 준비해 주셨습니다. 강연 제목은 Accurate Electrolyzer Cell Testing by Optimized Mass Flow Control입니다. 네, 여러분 큰 박수로 환영해 주시기 바랍니다.
Okay, thank you very much for the introduction. It's an honor to be here in Korea at this stage. Also the audience, very welcome to this session about Bronkhorst and about the topic that I have, the accurate electrolyzer cell testing by optimized flow control. First, let's introduce myself. I'm market developer for renewable energy. That means that I travel around in all the world to see what's happening in the renewable energy market and to learn what applications could be fit to Bronkhorst. I have an academic and research experience background. The last 10 years I worked in the Han University of Applied Sciences in Arnhem in the Netherlands. And before that, I have also industry experience in developing mass flow controllers and pressure controllers. So when we look to the products of Bronkhorst, we have mass flow meters and controllers for gases and liquids, pressure meters and controllers, and also vapor delivery systems. And we also offer customized solutions if you have special needs. We call ourselves the low flow specialists. We offer products for the low flow range, especially for testing applications, R&D, and small systems. We are in many markets, like, for example, the analytical market or the food and beverage, and all those markets we sell our products. But we have special interest in the renewable energy market. We believe that the renewable energy market is important also for everyone to have a green future. But if we look to this green hydrogen forecast, I took a picture of, I brought a picture, where's the laser pointer here, from the Hydrogen Insight of December 2023. And what you can see on this picture that the announced electrolysis projects, the huge projects, they are huge, they are enormous. They say that there will be, today we have 1 gigawatt of green electrolysis systems, and the forecast is that in 2030 there will be 305 gigawatt of electrolysis systems. And this is a huge forecast. And why do all those governments invest in those systems? Because they see that the global warming is now really visible. And that we see that, for example, things like the war in Ukraine caused that there is a lack of natural gas in Europe. And also, therefore, we need to find new ways to deal with that, to handle that. And hydrogen is one of the solutions. So of that 300 gigawatt, 90 gigawatt is announced in Europe and 4 gigawatt in the Netherlands. But is it possible to scale up so fast? And I made this picture, I show you this picture, promise the moon. This means we are promised that we can get the moon, but I think it's not possible. I think it will take much more time. We have a slower start, and this is what we see in 2024. That projects are delayed, especially when I look to Europe, where we are situated. We see that the market is too volatile. We see that capital costs increased enormously. Also, materials are more expensive. And the electricity price is higher than expected. And we see that there is also a delay in subsidies and regulations. If you want to build something, then you have to wait, and you have to wait for the governments to apply that you can do that. And there are technological challenges. And I want to focus today on the technological challenges. And the question is there still a business case? I brought some highlights from the newspapers that you can see. I don't want to go too deep into this, but that you see today in 2024 that projects are delayed. So there are technological challenges in electrolysis. For example, when you look to alkaline, which is the most ready technology for electrolysis, you see that there are, I don't say it's dependent on which manufacturer and which type exactly, but you see some things like that there are some problems in H2 crossover, that you have corrosion in the system, that there are safety issues, that the efficiency is not that high as they want it to be, and also that lifetime of those systems is not long enough for the investors to invest in those systems. It is not ready yet. When you look to PEM, which is the technology which produces more pure hydrogen, which is nice also for the automotive industry where you use fuel cells, that for PEM electrolysis also lifetime is an issue, that they want to reduce the costs of those systems, that there are expensive earth materials are used, rare earth materials are used in those systems. Efficiency is one of the points, degradation, and also pollution. SOEC is a technology which is in a much lower TRL level. It is still in development. We need to upskill the SOEC. And also durability and the high temperature causes issues that they want to improve. And for the last, I will show that there are also other technologies. AEM was also mentioned in one of the previous talks. Inapter is here with a booth. You can see that there are different other technologies, but those technologies are really new. A lot of them are in R&D phase. So my conclusion is that there is a high demand for test systems for electrolyzers. And when you look to an electrolyzer system, the core of an electrolyzer system is a stack. And the typical test system is just a balance of plant around such a stack. But a special balance of plants, a balance of plant where you can measure everything what you do during your test, because you want to that it's possible to reproduce your test and that your results are reliable. If you look to such a system, it consists, of course, of the part that produces hydrogen. And I made a picture like this, where I show that in the first part, the hydrogen is separated from the water. Then we have a water separator step and a valve. On the other side of such a test system, we have the oxygen exhaust and also the water separation from the oxygen. And of course we have the input of clean water with a pump and a circulation system to circulate the water in the system. And dependent on the technology, this is an electrolyte like KOH in alkaline, or it is pure water in a system. And in a PEM system, you also need, for example, to add water vapor to your system. So this is what we call a balance of plant. And in this balance of plants, you need a lot of instrumentation. For example, if you have an electrolyzer system, you want to pressurize the system, because after this system, you need to store the hydrogen. You need to go to higher pressures. So it would be nice if your electrolyzer can run on a high pressure. So you need a back pressure controller. But for example, in alkaline systems, it is important that the pressure difference between the oxygen and the hydrogen side is not too high. Because when this pressure difference is high, you get crossover of hydrogen to the oxygen side, which causes unsafe situations. When you have more than 4% of hydrogen in oxygen, you have a flammable mixture. You can add a flow meter to your liquid circulation system. that you make it a liquid flow controller together, and also your clean water feed can be controlled with a flow controller. And at the end of the system, you can add a flow meter to measure the hydrogen flow that you produced. What I'm missing still is the electricity source. You need to put electricity into the stack to let it run. And you can measure the current with a current sensor that you know how many current is flowing to your system. What is nice of the relation between current and the flow meter is that the current that you add here is electrons. The current sensor counts electrons, and your flow meter counts molecules. I will go into that deeper on the next slide. But first, Bronkhorst is a supplier of that instrumentation that I mentioned. For example, we have the back pressure controller. We can offer the differential pressure controller. We have nice ultrasonic-based mass flow meters for liquids that can be used, for example, for the KOH control of the electrolyte. We have Coriolis-type flow meters that you can use for your clean water feed. And, of course, we have thermal sensors to measure the hydrogen flow. Of course, you can also, instead of the large thermal flow meter that I show here, you can use there also a Coriolis type of flow meter. But a Coriolis type of flow meter has a lot of pressure drop. And the advantage of a thermal one is that you don't have the pressure drop. But what is important is that that flow meter is very accurate. And the reason why it needs to be accurate is because you want to measure the Faradaic efficiency. If you count electrons of the current that's flowing to the stack and compare it with the hydrogen that you produced, there is a strict relation between it. You need two molecules, two electrons to produce one molecule of hydrogen. And this is called the first law of electrolysis of Faraday. So if you can measure the hydrogen flow very accurate, you can see if there are leakages internally in your system, that if hydrogen is going somewhere else, by comparing the current with the hydrogen flow. So for the hydrogen flow meter, we have set up some specifications. It should at least be 1% accurate or better. And this means that you need a real gas calibration. Normally, thermal instruments are calibrated with a surrogate gas, like nitrogen, or with air. But you need here a real gas calibration with hydrogen. And the pressure range of such an instrument is somewhere between 10 and 60 bar. You want a pressure drop as low as possible. And sometimes you need also explosion protection for zone 1 or zone 2 that we also can offer. And the flow rate I placed here, if you have a 1 megawatt stack, you have a flow rate of around 200 cubes per hour of hydrogen. And now the next slides are about an invention of Bronkhorst, is how to calibrate such high flows. Because the traditional way, when you start with a bunch of bottles with hydrogen and a device on the test, your flow meter, which you want to calibrate and compare it with a reference meter, yeah, that is nice for low flows. But for higher flows, for 1,000 cubes per hour, for example, is it okay to vent it into the air? We say no, because you create an explosive, unsafe environment where you add all the hydrogen into the air. It is not good for the world. Hydrogen is an indirect greenhouse gas, and is also expensive. It costs a lot of money to calibrate in this way a flow meter for example, 200 cubes per hour. So what we did, we made a loop calibration system. We closed the loop. We reused the gas in a closed loop. We use a pump to pump the gas around. We have some temperature control in the system, and our device under test and the reference meter are placed inside the loop, and there we do the comparison. Of course, this is only a principal schematic. The real system is much more complex, and it looks like this. Here we see it in a flow cabinet, and the red line is showing where the loop is. And you see that there is the pump, is the blue one, the heat exchanger is in the bottom of the system, And the place where we can place the device on the test is here, and the reference meter is placed here. And with this system, we can do real gas calibrations up to 200 cubes per hour for hydrogen. So if we look to the relation between the power of an electrolyzer and the flow rate of hydrogen you produce, you see something like this, that we can cover now with the real gas calibration flows up to 20 kilograms per hour or 200 cubes per hour of hydrogen. And in the future, we want to build an even larger calibration loop for calibrating hydrogen instruments. So I will come to the conclusion of my presentation. So there is a strong focus on green hydrogen production via electrolysis. And we see in the world that projects are delayed, and one of the reasons is that there are technical challenges. Therefore, test systems are needed. And in those test systems, you need the most reliable test results, and therefore you need very accurate, real gas calibrated flow controllers. And because of this new invention of the real gas calibration system, our instruments have a next level of accuracy for H2. And with this improved instruments, your test systems will also be improved. Okay, thank you very much for your attention. You can meet us at our booth at J14 here at the H2 Meet. And I want to give the words back to you.
Thank you very much for your presentation. 네, 혹시 질문이 있으신 분께서는 손을 들어주시면 감사하겠습니다. 네, maybe they want to meet you at your booth. So thank you very much once again, and please return to your seat. 네, 큰 박수 부탁드립니다. 네, 브론코스트의 정확하고 신뢰할 만한 그런 검진 결과들도 볼 수 있었고요. 그럼 다음으로 강연 소개를 해드리도록 하겠습니다. 테크크로스의 CTO이신 권경환님께서 다음 강연을 준비해 주셨는데요. The alkaline electrolyzer system, adopting self-developed core materials and components directly connectable to renewable energy라는 제목으로 강연을 준비해 주셨습니다. 네, 여러분 따뜻한 환영의 박수 부탁드립니다.
안녕하십니까. 테크로스 CTO를 맡고 있는 권경환 상무입니다. 저희 회사에서는 국내 최초로 재생에너지 직결형 알카라인 시스템 개발 결과를 말씀드리겠습니다. 회사는 초기에 지금 여태까지는 선박 평형수 처리 장치로 글로벌 넘버1을 이제 기록하고 있는 회사입니다. 좀 생소하신 분야긴 한데 선박 평형수라는 거는 배가 짐을 실으면은 배가 무게가 무거워지고 그다음에 짐을 하역을 하면 배가 이제 가벼워지니까 물 위에 뜨게 됩니다. 그래서 굉장히 이제 위험하고 그 추진력에 문제가 있어서 이 무게만큼 대신에 물을 채우는데 그 물을 평형수라고 합니다. 이 평형수가 예전에는 그냥 바닷물을 채웠다가 뺐다가 하면 됐는데 이게 이제 뭐라 그럴까 그 해수 자원의 어떤 생태계를 교란한다고 그래갖고 전부 살균을 하도록 돼 있는데 저희가 20년 전부터 전기 분해로 해갖고 이 평형수 살균 장치를 만들고 있습니다. 그리고 현재 이 평형수 살균 장치는 전 세계 마켓시어 1위를 지금 달리고 있고요. 그래서 24년간 저희가 해왔던 이 전기 분해 장치를 가지고 죄송합니다. 지금 새로운 사업으로 진출을 하려고 그러는 게 이제 그린 수소 수전의 신사업이고요. 이거 역시도 이제 전기 분해를 기반으로 하는 겁니다. 그래서 저희 회사는 여기 보시다시피 한국 내에서 타의 추종을 불허할 정도로 훌륭한 성과를 쌓아왔습니다. 그린 수소 수전에는 불과 이제 3년 됐습니다. 21년도부터 본격적으로 개발에 참여하기 시작했고 21년 9월 달에 경기도 화성에 국내 민간 연구소 최대 규모입니다. 여기에 이제 그린수소 시험센터를 개설을 하는데 그 당시에 이제 과기부 차관님을 비롯해서 아주 유명한 인사분들께서 오셔서 개소식에 참석을 해주셨고 현재는 이 화성에 있는 연구센터가 부산에 있는 본원의 연구센터보다 인원이 많아져서 30명의 전문 연구원들이 근무를 하고 있는 상태가 되겠습니다. 이러한 노력을 인정받아서 저희가 20여 년간 그 해수 수준의 분야에서의 전 세계 글로벌 넘버원, 그 다음에 그린소 수준에 대한 투자, 이런 부분에 힘입어서 23년 3월에 한국 정부에서 주는 저온 수준의 분야의 으뜸 기업으로 지정을 받았습니다. 회사가 자랑하는 것은 그동안 선박평형수 전기 분야에 국한되었겠지만 이미 전 세계 2위의 규모에 있는 전극 공장을 가지고 있습니다. 그 전기 분야에 필요한 전극은 사실은 생명이나 다름없는 심장이나 다름없는 아주 중요한 부품인데 이 부품을 이 일렉트로드 전극을 저희 부산에 있는 공장에서 직접 생산을 하고 있습니다. 이 전극이 아시아에선 최대 규모고 세계에서는 이태리에 있는 디노라이에서 두 번째인 규모로 알고 있습니다. 이번에 그린소 수준에 저희가 새롭게 250kg용으로 개발을 한 전극의 모습을 보시고 계십니다만 이게 이제 부산에서 우리 전극 공장에서 생산을 한 물론 이제 개발 샘플로 생산한 거죠. 전극이 되겠고 전극의 시험 결과는 약 82.5%로 상당히 높은 효율을 자랑하고 있습니다. 아울러서 이제 부하 변동 테스트 결과 600사이클을 저희가 온오프를 했을 때도 거의 0.5% 내외의 퍼포먼스 내구성을 자랑을 하고 있습니다. 전극과 더불어서 알카라인 수준에서 가장 핵심 소재는 분리막이 되겠습니다. 현재 이 분리막은 글로벌 공급사가 굉장히 한정적이죠. 벨기에에 있는 아그파를 비롯해서 중국도 이제 몇 군데 있는데 이런 부분들을 저희들이 지금 개발을 하고 있고 현재로서는 굉장히 소규모긴 하지만 이렇게 조그만 롤트롤 장비까지 만들어서 50cm 정도의 시험 생산을 성공을 하고 있습니다. 만들어진 전극은 국제적으로 많이 통용되는 A사에 비해서 조직이 치밀하고 평균 기공의 지름이 약 35% 이상 작은 것을 볼 수가 있습니다. A사는 114나노메타인데 우리는 75.7나노메타로서 굉장히 조밀한 상태를 유지하고 있고 이 기공의 지름 분포도 분포가 굉장히 넓게 퍼져 있지 않고 한 군데 좁게끔 산포가 좁은 것을 알 수가 있습니다. 이러한 조밀한 기공 사이즈는 산소 내의 수소 농도를 굉장히 개선을 할 수 있는 퍼포먼스가 보여지며 아울러서 효율과 연관이 있는 아이오닉 레지스탄스, 저항이죠. 저항도 많이 개선이 된 걸 볼 수가 있고 기계적 강도를 나타내는 버블 포인트 역시도 상당한 폭으로 개선이 된 것을 알 수가 있습니다. 이러한 이제 핵심 소재 부품을 활용을 해서 저희들이 시스템까지 수직 계열을 하고 있습니다. 현재 수준의 시스템에서 가장 중요한 것은 스택이 되겠습니다. 저희 스택은 다른 회사의 스택들과 다르게 셀 모듈을 단일 셀로 교환을 할 수 있도록 설계가 되어 있습니다. 보통의 알카라인 수준에는 볼트를 이용하고 너트로 잠그는 그런 타입인데 저희는 오른쪽에 보이시다시피 사진에서 보면은 레일 프레스 방식으로 슬라이딩을 해서 압착을 하고 중간에 있는 어떤 셀이라도 체인지를 위해서 쉽게 빼낼 수 있도록 이렇게 모듈화되어 있게 되어 있습니다. 그래서 이 모듈 셀이 좋은 점은 기존에 있는 알카라인 같은 경우는 이제 주물을 이용해서 스테인리스를 가공을 하는데 굉장히 비쌉니다. 무겁고. 근데 저희가 이제 원가를 절감하기 위해서 대량 생산의 용량 구조로 지금 개발을 했고 양산을 염두에 두고 지금 개발한 결과가 되겠습니다. 아울러서 이러한 스택 개발과 더불어서 앞서 얘기했던 전극과 분리막을 만들어서 스택에다 집어넣고 그 스택의 구조를 유니크하게 만들었고 그걸 제어하는 방법에 있어서 아시다시피 전기 분해는 산소와 수소를 만드는데 항상 수소가 산소보다 2배의 부피로 생산이 되기 때문에 압력이 큽니다. 그래서 가만히 두면 가운데 있는 분리막에서 압차가 발생을 해서 수소 쪽에 있는 압력이 산소 쪽으로 넘어가도록 해서 산소 쪽의 출력에 수소가 어느 정도 섞이는 그런 섞임 현상이 발생을 하는데 이걸 최소화하는 것이 이 제어의 저희 목표가 되겠습니다. 그래서 보시다시피 뭐 기본적인 델타 P, 그러니까 압차죠. 압력 차와 그 다음에 그 알카라인에서 쓰이는 이제 전해액, 일렉트로라이트죠. 일렉트로라이트가 음극과 양극의 공이 이렇게 결합이 되어 있기 때문에 발생된 수소가 용존의 형태로 전해액에 녹게 되어 있습니다. 이 부분이 산소 쪽에도 일부의 수소를 혼재시키는 역할을 하는데 여기에 들어가는 전해액의 유량 그리고 가장 중요한 것이 분림학의 물리적인 확산 특성이 되겠습니다. 이러한 부분들을 제어에 활용을 해서 일반적인 차업 시스템으로 갔을 때는 저희가 전류량을 부하량을 낮췄을 때 1.46%의 크로스오버 수소량을 보이는데 테크로스의 복합 제어 로직을 사용하면은 약 4분의 1 이하로 이 크로스오버 되는 수소량이 줄게 됩니다. 그리고 아울러서 기존의 차압 방식의 일반적인 그 제어 방식을 사용을 하더라도 저희가 자체적으로 개발한 분리막을 적용하게 되면 분리막만으로도 15%라는 아주 낮은 부하에서 0.62%의 크로스오버의 아주 우수한 성능을 얻을 수 있었습니다. 이러한 성능을 바탕으로 해서 신재생 에너지에 직결을 해보자는 이제 아이디어를 저희가 추진을 했고 공동으로 개발에 참여한 한국의 서부발전 주식회사 석탄 화력 플랜트를 가지고 있죠. 이 서부발전에 보유한 1메가와트급의 태양광에 직접 연결을 해보았습니다. 왼쪽에 보시다시피 100%의 전격 전류를 꾸준하게 보내는 것은 사실 큰 문제가 없습니다. 그러나 이것을 점점 저전류로 전류량을 낮추게 돼서 부하를 낮추면은 우리가 15%까지 이렇게 낮출 때 여기에는 생산되는 수소의 플로 레이트가 따라가는 걸 볼 수가 있고 실제 태양광에 얻어지는 이 에너지의 파형은 이와 같이 얻어지는데 밑에 보면은 수소가스와 산소가스가 아주 이 태양광에 얻어지는 전류의 에너지와 함께 똑같이 따라가는 것을 보실 수가 있습니다. 최대 운전 부하 실험에서도 저희가 0에서 풀로드까지 가는데 약 10초 이내에 아주 빠른 특성을 구현을 하고 있고요. 보다 중요한 것은 지금 아마 얼마 전에 6월 달에 아마 중국 시노팩에서 260메가와트의 대형 수소 플랜트 실험을 마친 걸로 알고 있는데 그때 문제가 됐던 것이 수소 생산을 계약량에 비해서 약 5분의 1밖에 생산이 안 되더라. 그래서 굉장히 큰 이슈가 된 바가 있습니다. 그 이슈 중에 하나가 시노팩과 중국 정부가 계약을 한 것은 최대의 최저 부하 전류를 30%까지 약속을 했는데 실제로는 수소의 크로스오버의 안전성 문제 때문에 50%까지밖에 운전을 못했다고 합니다. 이러한 결과로 결국 생산량이 5분의 1에 불과한 그런 문제가 대두가 됐고 굉장히 이것이 이제 큰 기술적인 난제인 것을 이제 확인한 그런 플랜트 결과가 되겠습니다. 저희는 아까 얘기했던 이제 저희 당사의 분리막을 사용한 결과 약 10%까지 부하량을 줄였을 때도 0.65%의 굉장히 우수한 수소의 크로스오버 특성을 얻을 수가 있었습니다. 아시다시피 수소의 폭발 범위는 4%에서부터 75% 정도 됩니다. 그래서 통상 4%가 넘으면 굉장히 위험하기 때문에 2%부터는 이제 시스템을 셧다운 시키고 1%부터는 이제 알람을 이제 울리게 돼 있죠. 근데 알람이 계속되면은 사실상의 운전은 곤란하게 됩니다. 0.65%라는 것은 굉장히 우수한 이제 운전 조건이 되겠고요. 이것이 최저 부하 10%에서 이런 결과를 얻었다고 하는 점은 상당히 고무적이다 할 수 있겠습니다. 테크로스는 앞서 말씀드렸지만 21년부터 그린 소슈네를 시작을 했습니다. 얼마 안 되는 기간인데 올해까지는 태양광 연계 부하 변동 시험을 실증을 성공적으로 완료했고 내년서부터 본격적으로 그리드 밸런싱에 대한 실험을 26년까지 실시를 할 예정입니다. 이 그리드 밸런싱에는 퓨얼셀까지 같이 연계를 해서 실제로 그 그리드의 변화량에 따라서 수전의 추종성이 어느 정도의 퍼포먼스를 갖는가를 확인하는 그런 실험이 되겠고, 이게 성공하게 되면 바로 풍력과 태양광에 연결하는데 저희가 그때까지 2.5메가를 상업화를 할 예정이라서 2.5메가를 직접 연결을 할 예정에 있습니다. 현재 24년 말, 금년 말에 250kg짜리가 개발이 완료가 되고 내년까지는 1쿼터에 상품화가 출시가 될 예정입니다. 그리고 지금 2.5메가의 대용량 스케일업이 개발되고 있기 때문에 26년도에는 개발이 완료돼서 상품화가 될 예정입니다. 27년서부터 2.5메가짜리 대용량을 가지고 글로벌 서플라이 체인에 본격적으로 올라탈 예정에 있겠습니다. 자, 이상 발표를 마치겠습니다.
네, 좋은 발표 감사합니다. 네, 그럼 혹시나 질문이 있으신 분께서는 손을 들어주시면 좋은 발표 감사합니다. 그럼 자리로 돌아가 주시면 대단히 감사하겠습니다. 네, 큰 박수 부탁드립니다. 네, 선박 평형수 처리 글로벌 1위 기업, 세계적인 수준의 저희 국내 기업의 성과와 또 앞으로의 목표를 보니 정말 자랑스럽고 또 신재생 에너지 분야에서 활약할 미래가 무척 기대가 됩니다. 네, 그럼 이제 마지막 발표가 남아 있는데요. 카본 밸류의 CEO이신 고덕수 님께서 준비해 주셨습니다. Rotating Packed Bed Type CO2 Capture System, Cutting Edge Blue H2 Production 이라는 제목으로 강연을 해 주시겠습니다. 여러분 큰 박수로 환영해 주시기 바랍니다.
시작하면 될까요? 네, 안녕하십니까. 카본밸류 대표이사 고덕수입니다. 저희 카본밸류는 카본 밸류라는 이름에서 아실 수 있듯이 이산화탄소를 비롯한 카본 웨이스트를 보다 가치 있는 물질로 전환시키는 토탈 솔루션을 개발을 하고 있고요. 현재는 이산화탄소를 포집하는 장치 개발에 집중을 하고 있고 중장기적으로는 메탄올 등 이퓨얼 등으로 사업 영역을 확장해 나가고자 합니다. 저희 카본밸류는 2021년 설립된 스타트업입니다. 부산에 있는 조산해양 기자재 업체인 선복공업의 컴팩트한 제조 역량과 울산과학기술원의 원천 설계 역량을 바탕으로 21년 3월 설립을 하였습니다. 현재 저희 연구소는 울산과학기술원 내에 위치를 하고 있고요. 저희가 설립된 지 얼마 안 된 스타트업이지만 저희가 작년에 SK 에코플랜트로부터 연료전지에서 나오는 이산화탄소를 포집하는 실증 과제를 수주하여 현재 그 사업을 진행을 하고 있고요. 그리고 주요 인력들은 저희가 박사급, 석사급의 연구 인력들로 주로 구성이 되어 있습니다. 저희 공동 창업자이신 유니스트 임항원 교수님은 전통 화공학자이시고요. 근데 학교에만 계셨던 게 아니라 세계 최대 산업용 가스 회사인 린데에서 이런 원천적인 연구를 진행하는 연구들을 한 7년 정도 이상 디벨롭먼트 스페셜리스트로 근무를 하셨고 이후에 유니스트에 부임하셔서 이산화탄소 수소에 대한 기초적인 공정 연구들을 석박사급 인력들과 진행을 하였습니다. 그래서 저희 팀은 이러한 임항원 교수님 연구실에서 같이 오랫동안 수학을 한 핵심 박사 인력들이 같이 조인을 했고요. 그리고 저는 주로 기술 스타트업에 투자해서 이걸 상용화할 수 있는 디벨롭먼트라는 주로 투자회사에서 근무를 하였고 현재는 경영 총괄을 맡고 있습니다. 다음은 저희 기술 소개입니다. 이산화탄소 포집하면 많은 분들께서 좀 새로운 기술로 생각을 하실 수 있는데요. 사실 이미 상용화된 기술이 1960년대부터 상용화되어 적용이 되어 왔습니다. 기존에 상용화된 이런 습식 타입의 이산화탄소 장치는 이런 대형의 구조물입니다. 그래서 주로 내추럴 가스 프로세싱이나 이런 쪽에서 연에 수백만 톤의 이산화탄소를 캡처하는 장치로 이미 상업화가 되어 있고요. 원리는 간단합니다. 이산화탄소를 포함한 배가스가 나오게 되면 이러한 흡수탑과 재생탑으로 이루어져 있는 이런 큰 타워에서 흡수탑에서 이제 선택적으로 이산화탄소와 반응을 하는 솔벤트를 쏟아주면 그게 이산화탄소를 캡처를 하고, 그렇게 이산화탄소를 머금은 아민이라고 하는 솔벤트가 재생탑으로 옮겨지게 되면 120도 내외에서 탈착을 해서 순수한 이산화탄소를 포집을 하고 사용했던 솔벤트는 다시 재생을 해서 재사용하는 이런 간단한 스킴입니다. 하지만 이러한 제가 아까 말씀드린 것처럼 이렇게 수백만 톤의 상용화된 이런 기술들이 2020년대에 들어서 이제 어떻게 보면 이산화탄소에 제재가 가해지고 카본에 텍스가 붙여지고 이런 카본 프라이싱이 되면서 조금 더 이런 중앙 집중화된 쪽이 아니라 분산화된 폐기물 소각장이라던가 연료전지라던가 이런 중소형의 포집 니즈들이 커져가면서 이러한 기존 기술들이 적용하기에는 경제성에 있어서 굉장히 불합리한 면이 있었습니다. 그래서 저희는 이러한 중소형 배출원에 적합한 솔루션을 개발을 현재 하고 있습니다. 그래서 저희의 원리는 간단합니다. 아까 말씀드린 이런 컨벤셔널한 타워형의 경우 대부분 이제 중력의 힘을 사용을 하게 됩니다. 하지만 저희는 로테이팅 팩트 베드라고 하는 원심력을 활용하여 이러한 솔벤트와 기체가 만나는 이런 반응성을 높이는 매스 트랜스퍼를 높여서 이제 반응성을 높이는 게 저희의 핵심 기술입니다. 그래서 기존 이제 컨벤셔널한 스크러버 타입 대비해서 부피는 약 10배 이상 작아지게 되고요. 그리고 캐펙스, 오펙스는 약 절반 정도로 줄어들게 됩니다. 그래서 저희는 아까 말씀드린 것처럼 이제 원천 기술 자체가 이제 울산과학기술원 유니스트에서 시작을 하였습니다. 그래서 저희 핵심 기술은 좀 전에 말씀드린 이런 원심력을 할 수 있는 이런 로테이팅 팩트 베드 시스템이라고 하는 이런 시스템이 첫 번째 저희 핵심 기술이고, 두 번째는 이러한 이산화탄소를 포집하는 데 있어서 예를 들면 운영비가 100이 들어간다 그러면 약 70 정도는 솔벤트를 재생하는 데 들어갑니다. 그래서 저희는 이러한 운영 에너지를 줄이고자 자체 솔벤트를 개발을 하고 있고, 그다음 세 번째로는 저희가 이제 상업화해서 그런 이산화탄소가 배출되는 사이트에 적용된 이후에는 아까 말씀드린 그런 타워형과 같은 그런 스테이셔너리한 기술과 다르게 저희는 이제 동력원을 사용을 합니다. 그래서 이산화탄소의 배출량이라던가 그런 거에 따라서 좀 더 빠르게 대응할 수 있는 그런 옵티마이제이션된 소프트웨어까지 개발을 진행하고 있습니다. 그래서 저희는 이제 울산과학기술원 안에 공동연구실을 통해서 이러한 RPB 장치가 있고 솔벤트 스크리닝하는 장치, 그리고 저희가 대비되는 기술인 저희의 어떻게 보면 대비되는 기술인 컨벤셔널한 장치를 보유를 하고 있고요. 그리고 저희의 그 내부 패킹 머터리얼의 디자인이 중요해서 이런 것들은 빠르게 저희가 3D 프린팅을 통해서 출력을 한 다음에 빠르게 실험을 통해서 검증을 진행을 하고 있습니다. 그래서 제가 뭐 기존 기술 대비 원심력을 활용해서 매스 트랜스퍼를 높였다 이렇게 간단하게 말씀을 드렸지만 사실 이 반응기 안에서는 3상의 시뮬레이션이 필요합니다. 즉 패킹 머터리얼이라고 하는 고체상, 그리고 이산화탄소를 포함한 배기가스의 기체상, 그리고 이러한 이산화탄소를 선택적으로 흡수하는 이런 솔벤트, 액체상, 이 3상이 정밀하게 시뮬레이션이 돼야 되기 때문에 저희는 이러한 격자 모양에 따라서 아니면 이런 RPM에 따라서 이 안에서의 유동이 어떻게 되는지를 저희 자체 소프트웨어를 통해서 지속적으로 디벨롭을 해왔고요. 그래서 저희가 이런 패킹 머터리얼에 대한 디자인, 그리고 열 에너지를 이제 재생탑에서의 열 에너지를 굉장히 효과적으로 옵티마이제이션 할 수 있는 일체형 재생탑 등을 디자인을 하였습니다. 그리고 이러한 각각을 흡수탑, 재생탑을 별도로 제작을 해서 이걸 전부 다 실증을 했고요. 그렇게 해서 완성된 것이 우측에 보시는 이런 하나의 시스템입니다. 그래서 이러한 기존의 컨벤셔널한 타워형 대비 저희는 이제 원심력을 활용해서 굉장히 컴팩트한 것을 알 수 있고요. 가운데는 뭐 열교환기라던가 각종 이제 어그저리 시스템들이 들어가게 돼서 이것이 하나의 시스템으로 납품을 하게 됩니다. 그래서 직관적으로 이제 좌측에 있는 거는 하루에 한 100kg씩겠지만 높이가 한 4m 정도 되는 타워형이고요. 이렇게 굉장히 작은 양을 포집을 하기 위해서도 이렇게 굉장히 큰 타워가 필요합니다. 하지만 저희는 그거보다 포집량이 2배임에도 높이는 한 절반, 풋프린트가 이제 훨씬 더 줄어든 설비임을 알 수 있습니다. 그래서 저희는 이러한 벤치 스케일 타입의 시증을 통해서 일단 기존의 컨벤셔널 대비해서 이게 저희가 가설로 세웠던 매스 트랜스퍼나 이런 것들이 훨씬 더 이제 높아지는 것을 실험적으로 확인을 했고요. 그리고 또한 이산화탄소의 가스에서의 농도에 따라서 이제 기존의 컨벤셔널 컬럼 타입 대비 얼마나 저희 에너지가 적게 드는지를 모두 실증을 완료를 했습니다. 그래서 이러한 벤치 스케일을 바탕으로 저희가 현재는 커머셜 스케일로 지금 스케일업을 한 상태이고요. 그래서 저희가 이제 현재 상용화된 저희 이제 제품 싱글 유닛은 시간당 약 3,000 노말 루베 정도의 백가스 정도를 처리할 수 있습니다. 이를 기존 타워형으로 구현을 하려면 상용화된 아스펜이나 이렇게 시뮬레이션을 했을 때 대략 높이 13m의 굉장히 큰 구조물인데 저희는 높이 한 2m 정도의 컨테이너 안에 충분히 들어갈 수 있는 원 싱글 유닛을 개발을 해서 현재 제작을 진행하고 있고요. 이렇게 굉장히 컴팩트한 좌우 폭이 한 12m 정도 되는, 그래서 뭐 기존의 상용화된 컨테이너 안에도 충분히 들어갈 수 있는 사이즈로 아까 말씀드린 약 3,000 노말 루베 시간당 3,000 입방 정도의 백가스를 처리할 수 있는 설비를 제작을 완료하였습니다. 그리고 저희의 두 번째 핵심 기술인 솔벤트 개발을 위해서 저희는 자체적으로 이렇게 어떻게 보면 흡수탑과 재생탑을 빠르게 모사할 수 있는 솔벤트 스크리닝 시스템이 있고요. 이를 바탕으로 해서 여기 가운데 빨간 기준 라인이 상용화된 모노에탄올 아민을 약 30% 정도 썼을 때 필요한 재생탑에서의 열 에너지, 그리고 이러한 솔벤트 하나가 얼마나 많은 이산화탄소를 머금을 수 있는지를 나타낸 도표입니다. 그래서 저희는 이런 경쟁 기술 대비 훨씬 더 적은 열 에너지, 그리고 훨씬 더 많이 이산화탄소를 포집할 수 있는 그런 솔벤트를 개발을 스크리닝을 하였고, 이 중에 기존의 타사 대비해서 특허성을 가지고 있는 녹색의 솔벤트들을 현재 계속 디벨롭을 하고 특허 포트폴리오를 구축을 하고 있습니다. 그래서 보시다시피 이제 기존의 상용화된 MEA 30% 대비해서 이제 열 에너지가 훨씬 더 적게 들어가는 것을 알 수가 있고요. 그리고 이제 이러한 이산화탄소 솔벤트에서의 열 에너지 외에도 또한 이제 산소나 이런 거에 반응하면서 디그레데이션이 빨리 일어나는 문제가 있습니다. 그래서 저희가 개발하고 있는 이제 카본 밸류 솔벤트 3 라인업의 경우에는 이제 산소에 대해서도 훨씬 더 강건성을 보이는 것을 이제 롱텀 테스트를 통해서 이제 확인을 하고 있고요. 그리고 또한 기존의 MEA는 이산화탄소가 잘 잡히는 대신에 독성이나 이런 것들이 심합니다. 그래서 부식성 또한 심하고요. 그런 부식성들을 측정하기 위해서 1년에 몇 밀리미터 정도의 이제 thickness가 로스가 되는지를 측정을 하는데, 일반적인 상용화된 아민 대비 저희는 약 10분의 1 정도로 이제 그런 코로전도 훨씬 더 작은 것을 알 수가 있습니다. 그래서 저희의 비즈니스 모델은 이러한 저희의 아까 이제 그 스키매틱으로 보여드린 저희의 장치를 단품으로 납품하는 경우도 있고, 또는 EPC를 저희가 턴키로 수주해서 이제 그 범위 내에서 공급을 하는 방법도 있고, 중장기적으로는 카본 캡처 애저 서비스라고 해서 저희가 뭐 정수기를 쓰듯이 그런 렌탈 모델로 저희가 이제 포인트 오브 소스에서 이제 이산화탄소로 고충이 있는 기업을 찾아가서 그거에 대한 토탈 솔루션과 스트럭처링까지 진행하는 것을 비즈니스 모델로 삼고 있습니다. 그래서 저희는 앞서 말씀드린 것처럼 21년 3월 설립된 스타트업임에도 감사하게도 SK 에코플랜트와 그리고 남부발전과 그리고 선보 유니텍과 함께 이제 강원도 영월에서 연료전지 백가스에서 나오는 이산화탄소 포집 장치를 현재 실증을 하고 있고요. 이러한 연료전지는 현재 이제 그 내추럴 가스를 써서 이제 발전을 하고 있어서 일부 이산화탄소가 발생을 하는 상황인데, 이를 모두 포집을 해서 이제 완벽한 친환경 에너지 그리고 텍서너미를 맞출 수 있는 시스템으로 저희가 대기업과 함께 실증을 하고 있습니다. 그래서 이러한 육상에서의 연료전지 외에도 저희가 이제 이러한 저희의 장치를 가지고 접근할 수 있는 이런 중소형 사이트들이 많이 있습니다. 그래서 저희가 바이오가스, 그러니까 사람이 음식물을 먹거나 이제 동물의 배출물에서 나오는 그런 그런 이산화탄소 거기서 이제 메탄과 이산화탄소가 나오는데 그런 이산화탄소를 포집하는 바이오가스라던가 또는 이제 선박이라던가 해양 플랜트와 같이 이제 풋프린트가 제약이 있는 그런 곳에서의 저희가 지금 피저빌리티 스터디를 진행을 하고 있습니다. 그래서 저희가 이제 카본 밸류는 이제 어떻게 보면은 원천 설계부터 이제 솔벤트까지 전부 다 국내 유니스트 기술로 그거를 이제 전체적 밸류 체인을 모두 다 개발을 하고 있습니다. 그래서 뭐 세계적인 기업들하고도 경쟁을 할 수 있는 그런 원천 기술을 가진 기업으로서 계속 발전해 나가도록 하겠습니다. 경청해 주셔서 감사합니다.
네, 좋은 발표 감사합니다. 네, 그럼 질의응답 시간을 가져볼까 하는데요. 질문이 있으신 분께서는 손을 들어주시기 바랍니다. 네, 질문이 없으시면 이것으로 강연을 마치도록 하겠습니다. 감사합니다. 네, 카본 밸류가 가진 로테이팅 팩트 베드 시스템이라는 핵심 기술과 또 개발 진행 현황을 잘 공유해 주셨는데요. 앞으로의 발전 기대해 보겠습니다. 그럼 이상으로 테크토크 토픽 3의 마지막 세션을 마치겠습니다. 참석해 주신 모든 분들께 다시 한번 깊은 감사의 말씀 드립니다. 9월 27일 내일도 이곳 컨퍼런스 스테이지에서 테크토크 세션이 계속됩니다. 오전 10시 20분부터 Harnessing Hydrogen, Advancing Mobility, Industry and Technology in Strategic Projects라는 주제로 토픽 4 세션이 진행될 예정입니다. 여러분들의 많은 관심과 참여 부탁드리겠습니다. 네, 그럼 모두 조심히 돌아가십시오. 감사합니다.